Hello everyone, I'm Creative Product Design Section 3, Team 4, Junsong Park. Our table of contents is as follows. Due to difficulties in production, we changed our concept of the product and analyzed stress and deformation by peer feedback. And we select our y-axis motor by calculating speed and torque through a detailed formula. When we planned the Wallozet, we estimated space efficiency was 20% higher than general closet. However, the size of the driving part was larger than expected, resulting in reduced space efficiency. The additional space efficiency of 20% reduced to 10%. We tried to market it to the general public for good space efficiency, but we decided to change the sale target and sell it to people who really need it. We also wanted to increase the stability, durability, and speed of driving to increase the satisfaction when the elderly, children, and patients use the Wallozet. So we did a detailed study of motors and screws. This time, it's peer feedback. This is an action body from Wallozet. Action body is the most important part of the Wallozet, which moves on the X, Y, and Z axis and pulls out the desired cell. Through ANSYS, the stress was analyzed considering the actual weight and material of the action body. The highest pressure measured is 1.7684 megapascal. Since the yield stress of ordinary metal is more than 100 megapascal, the stress on the action body is safe. We analyzed the action body's deformation too. The action body predicted that there would be quite a lot of deformation as it operates up and down through a lead screw in both holes. As measured, the highest measurement was 2.2807 times 10 to the power of minus 4 millimeter. This is the value before reaching the normal elastic limit of the metal. So it will be safe because the action body performs elastic performance when it is operated normally. This time, it is calculating the speed of the y-axis motor. The required motor RPM X was 600 or more because the y-axis motor has a driving time of 6000 over X seconds and the target speed is 10 seconds. The torque of the y-axis motor can be calculated through the lead screw. Because the ratio of spur gear and bevel gear is both 1:1. The following expressions allow you to calculate the force and torque required for lead screw. The theta is a lead angle and the phi is the friction angle determined by the friction coefficient of the lubricated metal. The minimum torque of the motor obtained by the calculation is 1366 Newton millimeter. The motor we found during the investigation is a deceleration gear motor with 1/3 of the deceleration ratio shown in the figure. The motor has a torque of 2998 Newton millimeter and 638 RPM. This can move y-axis action body of the Wallozet. Our future work is as follows. We will implement simulation through BREP and select specific parts. Also, we are working on code structure that drives Wallozet. Thank you for listening to Section 3 Group 4's presentation. See you next week.